Hello, and welcome to today's webcast, NetApp Performance Troubleshooting, Essential First Steps and Best Practices. I'm Danielle Moore, Marketing Manager at Datalink, and will be your moderator today. Before we begin, I wanted to cover a few housekeeping items. This webcast is designed to be interactive between you and the presenters. The webcast console you are looking at can be completely customized. You can resize or move any of the windows that you have open. At the bottom of your audience console are multiple application widgets you can use. If you have any questions during the webcast, you can click on the Q&A widget at the bottom and submit your question. All questions from this webcast will be captured. If you are experiencing any technical difficulties, please visit the webcast help guide by clicking on the question mark icon below the presentation window. The help guide covers common technical issues. I would now like to turn this presentation over to our presenter, Ben Richter. Ben, the floor is yours.
All right, thank you, Danielle. Welcome, everybody, to the NetApp's Performance Troubleshooting for 7-mode and C-mode. I'm your host, Ben Richter. I'm one of our advanced NetApp support engineers here at Datalink, and I focus a lot on performance troubleshooting. Today we'll be covering some of the tools and techniques that Datalink support uses when you open a performance case. Today we'll be discussing some of our performance framing questions. We're going to do a Perfstat overview. We're going to do an overview of Latx. We're going to discuss some common bottlenecks, talk about back-to-back CPs, and then open things up for questions. Performance framing questions. We've compiled a list of 8 simple questions we ask every user who's experienced a performance issue. Question number 1 is, what is the nature and business impact of the performance issue? Basically here, we're trying to get an understanding of how many users are being affected and if this is having any impact on revenue. The reason this question is very important is if we're in a situation, especially a P1 issue, and we need to get NetApp's help with this, that is one of the first things when we open a P1 case with NetApp that they want answered. So that is why we try to get that up front right away. Moving on to question 2, we want to find out how are you guys measuring your latency? You're looking at the clock on the wall. Are you using on-command performance manager? Are you getting it out of your ESX graphs, or are you looking at a Perfstat yourself or some sort of Sysstat output? Question number 3, when was the issue first observed? Trying to figure out, is this issue happening now, or did it start a week ago, an hour ago, a day ago, so on and so forth. Question 4, were any changes made around that time or shortly before? Changes to the storage, the network, software, firmware, that's all important information for us to have. Moving on to question 5, were any backups, virus scans, or dedupe jobs or other activities running during the time of the issue? Ask that question because many times we have a system that's already being highly taxed, and we find that, say, when a dedupe job is running during the day, it sends up the latency. Or if a backup job is running at night, you see a spike in latency. So that's why we're asking for that information. Question number 6, are all users, VMs, LUNs, volumes, filers affected? So basically what we're looking for here is in 7-mode, you normally have a system with 2 nodes, so we want to know which node is that on, what volume is being involved. If there's a LUN being involved, what LUN that is. From that information, we can go take a look at what aggregate you're using, take a look at your sysconfig-r to find out what kind of dis compose that aggregate. For C-mode, normally you have anywhere from 2 to 8 nodes involved, so we want to figure out which node it's on, which SVM you're having an issue with, and then from there, which volume or LUN. So we can do the same thing that we do in 7-mode, look at the aggregate and which disks are involved in the aggregate. Question number 7, what is the protocol and basic topology? So for networking protocols like NFS, CIFS, and iSCSI, we want to know, are you using 10 gig? What kind of switches are you plugged into? For fiber channel, we'd want to know what speed you're using. Is it fiber channel 2, 4, 8 gig, so on and so forth. Question number 8, was a Perfstat collected during the time of the issue? The reason we ask that is many customers who have opened multiple performance issues with us have kind of found that when we do this performance troubleshooting, we always ask that you collect a Perfstat during the time of an issue. Now, of course, if you've never opened a performance case before, that's not something that you would know. So many times we get customers opening their first ever performance case and saying, hey, I've generated an auto support. Can you go look in there? We will do that for you, but it's very difficult for us to get you any sort of RCA unless we have a Perfstat to look at. And most importantly, we need a Perfstat collected during the time of the issue. Perfstat data is not historical data. It only runs while you're collecting it. So if you had a performance problem today at noon, and then the problem went away and you collected a Perfstat at 1 p.m., we would not be able to tell anything from that Perfstat because that would only be collecting the data at that time. Moving on. So Perfstat for C mode. For C mode, we use the 8.3 GUI. And there's a KB article that walks you through the different options. I have a link up on the slide that gets you to both the Perfstat 8.3 GUI and the Perfstat 8.3 GUI KB. But on the screen here, you see that we can enter in our cluster management IP, the admin password, and the diag password. Another important note is that when you do enter in the diag password, you have to have at some point enabled the diag user. And there's a KB about how to do that as well, but most customers have that enabled, so that's not a very common issue. You can also select the time and iterations and then run it. Or there's an option down here to schedule it to have it run later or to have it capture multiple Perfstats. Perfstat for 7 mode. For 7 mode, we use the GUI for NetApp support tools, and you can see I've included the link here. Very similar to the C mode one, we enter in the IP or name of our controllers. We enter in the root username and the root password. We select the iterations and time, and then we can run it. There's also a feature here to schedule this to run at a later time. Now we're going to discuss a little bit about Latx. Latx is NetApp's internal tool for analyzing Perfstats, and only NetApp and Datalink have access to this tool. So you, the customer, won't be able to use it. I'm really only showing this to you so you, the customer, understand what is support doing once you upload that Perfstat to us. This is the summary view. This is kind of the first thing we see when we upload a Perfstat into Latx. You can see here on the screen that we see some red dots on some peaks here. You also see some blue bars down in the middle of the page on the right side that show high latency for certain iterations and allows us to quickly get to the right iteration. For an example, on the right side in the middle of the page, you can see there's one large bar for the 4th iteration, because it's the 4th bar in, for average op latency, and a large bar at the same time for write latency. This would obviously give us a good indication that there's probably an issue occurring in iteration 4 and you're having high write latency. This is the report view. It has some good latency reports that allow us to look at latency for a couple different layers. Here on the slide, you can see we can look at the protocol layer, the disk layer, the LUN layer, and the volume layer. Once we identify the layer, we can also see what iteration the latency occurred in. On this screen, I happen to have the disk layer selected, And we can see iterations 1 through 5, and we can see the different aggregates, aggregate 0 and 1, and we can see some of the different latencies we have. Average read latency and average write latency are a couple of them. Latx also has a graph view. Here there's just a lot of different graphs for protocols, and we usually use these when we're troubleshooting protocol and network issues. On this example here, we can kind of see that the CPU busy is going up as the FCP ops are going up. So you can kind of correlate that at times when you do more operations, your CPU goes up, which makes sense. This next slide, we're going to cover latency reports. The latency report view lets us quickly identify high read and write latency and which iteration it may have occurred in. It's very helpful in sending us in the right direction, and this is actually normally where I start when I look at a Perfstat. Here in this example, you can see all 5 iterations, some information about the CPUs, some information about the NFS, the CIFs, and the fiber channel and iSCSI ops. Total ops, we're seeing average latency for reads and average latency for writes. Then we can go into the View Perfstat section of Latx, and here we have lots of output like the DF, the ifstat, the lunstats, NFSstat, and a whole bunch more. Now, what a Perfstat is really doing as it's collecting is it's just sending commands to the filer saying, hey, run a Sysstat-m, hey, run a Sysstat 1 second output, and it's just throwing it all into one huge text file. And then this Latx tool is taking that and parsing it out for us and sticking it in different sections. The Latx, i.e. the Perfstat, gives us a lot of info, but it's only for a short period of time, usually 3 or 5 minutes, depending on your iteration length. And it's very granular. This is why support doesn't use OPM, which is On-Command Performance Manager, to troubleshoot performance issues. OPM's data is a little less granular and averaged over longer periods of time. OPM is a great tool for you, the customer, to help identify performance issues, but the Latx and the Perfstat is the tool that support is going to use to help you find the root cause of that performance issue. Now we're going to go into some of the common bottlenecks, which are network, disk, and CPU. These are the 3 most common bottlenecks we see. And I would say of those 3, I would say that disk is the one we run across the most. Spinning disk is usually the slowest part of your storage. SSDs are starting to move that bottleneck to different parts of the storage the same way 10 gig did for the network. Previously, when we had 1 gig NICs, we saw a lot more networking bottlenecks, but now with 10 gig, we just don't see many networking bottlenecks. And I'm sure someday when all of these SAS drives are replaced with SSDs, that latency will move to a different point on the storage controller. All right, let's dive into these. So on this first slide, we're looking at, for networking, we're looking at the ifstat-a. And the main thing we're checking here is flow control. Flow control should be set to none on all 10 gig cards. We're also looking for errors and pause frames. Pause frames will occur if you have flow control turned on. One thing worth mentioning is that all the CNAs out there, they don't allow you to set the flow control to none. So if you're using a CNA for networking, you actually have to go make that change on the switch. This is my only slide for network latency because it's not something we run into often with 10 gig, but in most Perfstats we get, I usually do go check flow control, make sure it's set to none, because that is a best practice for 10 gig. and it helps solve a lot of networking latency issues. So anytime I'm looking at a Perfstat for a customer, even if I know it's a disk issue, I'll take a look in here and let them know that, hey, flow control, if it's not set to none, I'll let you know that it's not, and recommend that you make a change to that somewhere down the road, just so you're following best practices. So now we're going to start discussing troubleshooting disk latency. So when I'm going to troubleshoot disk latency, I usually like to start out at the sysconfig-r, so I know what kind of disks are in the system. In this example here, we see we have BSAS disks, which are 7,200 RPMs, and they usually handle around 40 to 60 IOPS per disk. That's kind of their sweet spot. The other disk types we commonly see in systems are SATA, which is the same as BSAS. We also have fiber channel disks and regular SAS disks that usually run at either 10,000 or 15,000 RPMs. And those are your faster disks. Moving on to Sysstat. As a customer, you can use the Sysstat to get a good indication of what is occurring on your system. Notice in this Sysstat that in almost every line here, we see that the hard drives are being utilized at 100%. So if we see that in a Sysstat, we're going to want to go dig deeper into what the disks are doing. And the section we're going to want to look at is the Statit, and we'll talk about that on this slide. So as a customer, you guys can actually get this output from a Statit. The way you run a Statit is you have to go into diag mode and run a Statit --B to start the capture. Wait a minute or two and then do a Statit -E to end the capture. Make sure that you're logging your PuTTY session to a text file because you're going to get a lot of output. Notice on this screen here that we have our UT percentage, which means utilization percentage. It's around 98%. And this sort of correlates with what we were seeing on the previous slide with Sysstat, where the hard drive utilization was 100%. Now, the thing to be aware there with Sysstat is it actually reports the utilization of the highest utilized disk. So you could have a scenario where you have one disk running at 100% and all your other disks running at 5%, and Sysstat could mislead you a little bit where you might be thinking all your disks are running at 100%. So that's why we want to look at the Statit, because it'll give us a better indication of what each disk is doing. You notice here the first two disks in each aggregate is only being utilized a little bit, and that's because those first two disks are actually your parity disks. So they're not doing as much work. They're just getting parity calculations written to them every once in a while. And also remember from our sysconfig-r slide that these all are BSAS disks, which, as I stated before, are probably better designed for 40 to 60 IOPS. And here we'll notice that each disk is doing right around 120 IOPS. So this is a good indication that we're probably going to find some latency, probably in both read and write latency, which we'll discuss and show you how you calculate in the next slide. So from the Statit output, we can do some math to find out what our read latency is. Here you can see I just took one disk. It was 0B.01.2. It was being utilized 96%. Its XFERS, which means IOPS, is 117. 107 of those IOPS are reads, and we are seeing a read chain of 6.5, and we're seeing read USEX of 7,800. So if we take this chain time USEX, that will help us calculate the read latency. So in our example here, we took 6.5 times 7,883, and we get 51,000 USEX of read latency. If you take that and divide it by 1,000, that converts it to milliseconds. We're getting almost 52 milliseconds of read latency. So going back to Latx and its latency report, the port can actually use Latx to help us identify that latency just in the on the one screen. Normally, once we use Latx to identify that latency, we'll then go in to those other sections in the Perfstat that we covered, both the Statit and the Sysstat, and we'll kind of make sure that we do the math to make sure that all adds up to what we're seeing on this screen, just to kind of double check our work. So now we're going to move on to the next bottleneck, which is CPU. For CPU bottlenecks, we don't want to use the CPU percentage found in the Sysstat output, the normal Sysstat output. We actually want to use the Sysstat-m. When you run a Sysstat-m, you can see what all of your cores are doing. Now in this example, there's 8 cores, CPU 0 through CPU 7. And from this, we could say we are CPU bound. We notice that there's a whole bunch of 100% in there and a lot of 96 and a lot of 97s. Once we would identify those high numbers here, we would then go dig into other sections of the Perfstat to find what workloads are driving up that CPU. So you, the customer, can make changes to workloads or dedupe schedules and so on to help bring that down. That's my only slide on CPU. That's really the only spot we look when we're talking about CPU bottlenecks. So now we're going to move on to the next slide, which we're going to discuss back-to-back CPs, which are writes in NVRAM that can't get to disk fast enough. So a back-to-back CP occurs when one CP, which is a consistency point, happens, and during the process of the CP writing to disk, another CP occurs. They are almost always tied to a write bottleneck. Here in the Sysstat-x, you can see I've highlighted some CP types of BN, which means back-to-back CPs. This Sysstat output would be a good indicator that you're having a write issue, and you would probably be seeing high write latency. This could be being caused by either disk issues, which we could find from Statit, or CPU issues, which we could find by looking in Sysstat-m. So we'll move on to looking at the Statit for writes. Previously, when we looked at Statit, we were looking at the reads and the chains and the read usex. Now we're going to focus on the sections that's all right next to writes there, writes, chains, and usex. And we will use these numbers to calculate write latency. Remember that high write latency usually creates back-to-back CPs. So doing the math for write latency is identical to what we did back on our last slide for reads. We're looking at that one disk, 0B.01.2. It was being utilized 96%, was doing 117 IOPS. If you remember from that last slide, I believe around 102 of those IOPS were reads. 112 of those IOPS were reads. The other remaining 5 were writes, and our write chain is 25, and our write usex are 1200. So again, we take this change times usex, 25 times 1200. We're seeing 30,000 usex of write latency. We divide that by 1,000. We're seeing about 31 milliseconds of write latency. So you know how to do all that math. You can figure out just by looking at the stat at both your read and your write latency that's coming from disk. So once again, we can get that much of that data out of Latx in looking at the for C mode, we would have to look at the latency report, and the other slide I was actually showing you what we would look at for 7 mode. So for C mode, we'll go into the report section and look at our disk layer, and we would see that in iteration 1, aggregate 1 was seeing 16,900 usecs of write latency. Now I know that math doesn't add up from our last slide, but I actually pulled this example from a different report than for a different filer than I did the previous slide, because I didn't have one that added the exact numbers up. So, but in that previous slide, the 30 milliseconds we would have calculated would have showed right around 30 if we would have looked at the same report within the C mode for Latx. So that concludes my presentation. Please let us know if you have any questions. If there's something we cannot answer, we'll try to find an answer for you and get back to you at a later time. Thank you, and I'm going to turn it over here quickly to Danielle, and then we'll see if you guys have any questions. Thanks.
Thanks, Ben. So again, if you have any questions, you can type them into the Q&A widget at the bottom. Okay. So we did have one question. What are the start-stop commands for the Statit?
So again, these commands are only available in diag mode, and they are Statit --B as in boy. And then once you've started a Statit, you wait, 30 seconds, a minute, 2 minutes, however long of a time you want it to run for. And then you do a Statit --E to end it. And then that will throw an output to your screen very similar to the examples I showed you in the slide.
Great. So the second question is, how do you turn off flow control on a VIF? Do you have to destroy a VIF first?
I do not believe you have to destroy the VIF to turn off flow control. That actually gets set at the interface level. So you would actually want to probably do this during a downtime window, because if you change flow control while the card's up and you're serving data, there's actually going to be a little hiccup in the networking. But basically, it's the ifstat flow control off for that interface command, for that interface. In 7 mode, you would normally set that in your RC file, or you could just type the command in. But if you just typed it in and didn't change it in your RC file, next time your controller reboots, those settings will be lost.
Okay. Does OC Perf Manager do anything other than run these commands and log them to a database?
I'm sorry, which one was that?
Does OC Perf Manager do anything other than run these commands and log them to a database?
So OPM is On-Command Performance Manager, and it does a lot more than just running these commands that are included in Perfstat and put them in the database. It keeps track of a lot of other stuff. We've actually did a good Tech Tuesday a few weeks back on OPM that you might want to go watch the recording of that discusses in depth kind of what OPM is doing.
Okay, next question. What is the difference between collecting the Perfstat and collecting the performance counter from On-Command Console Performance Advisor?
So again, a Perfstat is going to go run and collect data live at that time that the Perfstat's running, and it's going to be very granular data. For example, we usually ask that you'd run 3 iterations for 3 minutes. So each iteration is just only going to collect that data for 3 minutes, whereas On-Command Performance Manager is running that data on your system kind of constantly and is averaging it over a little less granular and averaging over longer periods of time.
Okay, next question. During a high CPU scenario, is there a way to tell what process is taking up CPU cycles?
There is, but it's not a not a simple answer that I can share with you over this, because there's not a command that we can just type in to see what CPU cycles are. We have to go into the different things in ONTAP and, for example, look at what waffle is doing. So it's something that gets a lot more in depth, and there's multiple sections to look at it, and it can't really be covered with just one command. And then, of course, it varies between both 7 mode and C mode.
Okay. Well, I think that's it. If your question was not answered, we will follow up directly with you. Thank you for attending today's webcast. An on-demand version will be available within 2 to 3 days, and you will receive an email notification once it is available. Thank you again for participating in today's webcast.
So I just want to mention one